So, yeah, sticking with the security theme, I'm going to start talking about some of the topics that Miko touched on, particularly compromise, users' passwords being stolen by the guys in Russia and Ukraine and Estonia and those kind of things. And then Greg's going to come out afterwards and talk about encryption, which is another way to really protect yourself from the external threats which are happening to all of us. So, this new thing is actually a new product. I was here a year ago at the OX Summit. Before I joined OX just under a year ago. And this wasn't a product. This was some sort of proof of concept that actually the Power DNS guys and Dovecot guys have been working on jointly. And we've now turned it into a product, Dovecot Anti-Abuse Shield. Now, this is part of Dovecot Pro, but just like everything else we talked about and everything else at OX, and as Miko just said, this is actually based on open source. This is available on GitHub. Anyone interested in contributing to it, come and see me afterwards. That would be awesome. So, Dovecot Anti-Abuse Shield. It is a part of Dovecot, but it also works with AppSuite as well, and other things which I'll talk to you about. So, a lot of you guys, anyone who's running a mail system knows about the problems of abuse of that mail system. These guys attacking your mail system all the time. They're trying to brute force passwords. They're trying to use compromised accounts to get access, to send spam, to compromise computers, all of these kind of things. And lots of you will have protections on the SMTP side of things. So you're going to be doing things like rate limiting. You're going to be doing things like GUIP limiting. So this user shouldn't be in Nigeria when he was just in London 12 minutes ago. Trying to detect compromised accounts so you can clean them up, get the users to change their passwords, these kind of things. So limiting the abusive behavior. And this is just so important. Only, as you all know, a couple of weeks ago, the Yahoo hack, 500 million, perhaps more, username and passwords stolen. I mean, they were in bcrypt format, so hopefully they didn't just immediately have access to them, but then this just generates a huge rise in brute forcing and people trying to use those credentials that they found to try and get into those people's accounts and abuse them. So this has been going on a long time in the SMTP side of things, in your MTAs, and probably, hopefully, most of you guys have got protection on that side. One thing that's been missing for a long time is the Dovecot, the IMAP, POP side of things, and the webmail side of things. If any of you guys have got systems in place right now, it's probably homegrown. You probably built something, and some of the things you might be seeing, you might go, oh, hey, we've built something a bit like that. But this is essentially a product now. As I said, it's open source, so consider this a bit like, if you like, fail to ban for webmail and IMAP and POP servers. So there hasn't been like a real solution out there. Now there is. Okay, so let's just walk you through some examples. So you're detecting password brute forcing. If one person's doing it, typically you're going to see this is hopefully relatively straightforward. So someone logs in as, I say, Mike Ganson with a particular password. What we're going to have is Dovecot Anti-Abuse Shield, and this sits behind the rest of the stuff. So this is basically like a back-end piece. This isn't like accessible directly. This sits behind, and this is collecting data and figuring out what's going on. So someone tries to log in, Dovecot or AppSuite is going to ask Anti-Abuse Shield, what's going on? Should I allow this connection? Should I allow this login? And Dovecot Anti-Abuse Shield basically has built up statistics, which I'll show you, which determines basically whether this login is allowed. And it consists of two main components. We've got an in-memory stats database. Now, stats databases, if you're looking at trying to detect abuse, what you're trying to do, ideally, is detect what's happening over time. You're trying to build up a picture of behavior over time. Because I don't know, Dovecot Anti-Abuse Shield or any system doesn't know off the bat whether someone's account is being compromised, or you don't have prior knowledge necessarily. So you have to build up that knowledge. So this is a stats-based database that's time window-based. So it essentially builds up time windows of statistics, and then you can query those time windows. You can say, I want to see what this guy's been doing over the last hour, 10 minutes, day, whatever you want. And then there's statistics in those databases, and using some really nice algorithms for doing statistics, things like hyperloglog, which is a really efficient way of counting cardinality. So finding things like, hey, if I throw a bunch of passwords in here, it'll actually tell me with a very memory efficient and CPU efficient mechanism how many different passwords I threw in there, which is really useful. If you're trying to detect abuse, you want to do things like, how many times did this IP request to log in, but also how many different logins did this IP use in the last 10 minutes? Because if an IP is using like 1,000 logins in the last 10 minutes, either that's a NAT and a big NAT, or it's someone trying to brute force a whole bunch of different logins. And similarly with passwords, we can do things like, how many times was a different password used unsuccessfully to try and log in this account over this time period? Now, this is really interesting data that we can use to figure out if this was a bad login. Now, the second thing we have is this rules engine. So the rules engine is based on something called Lua. Anyone who's a gamer in the room may know Lua because it's used for things like World of Warcraft and things like that. Right? You can do configuration with Lua. It's a really nice, very efficient, very small, compact language. And what we're using that for is essentially to write policy. So this rules engine is a way for deciding what kind of stats you want to store, given the data that you want to analyze, and then using Lua to figure out the rules based on those stats to what you want to do. So it's essentially like a toolkit. We give you a policy, a default policy, which gives you some fairly straightforward ways of detecting, like brute forcing passwords and these kind of things. But you can also go as sophisticated as you want. You can make this a real sort of mega anti-abuse system. And the nice thing is, everyone's system is different. There is no one-size-fits-all with abuse and criminals. The bigger you are, usually the worse and more complex your problems are. But if you're in Italy, you're going to have the different kind of abuse than that people have in the UK or Germany or the States or whatever. So the idea here is we're giving you a toolkit to really customize this abuse to the kind of handling to the kind of abuse that you actually get. So it's going to ask questions. It's also going to send it data, right? This thing needs data. So it asks, should I allow this login? If we say yeah or no, then we send another piece of data, which is all the information about the login. So the IP address that logged in from, some kind of hash of the password, and it's actually really interesting. We just take a very truncated hash of the password. I think there's only about 4,096 combinations, which means that we don't have enough information to be able to leak the password, no matter what kind of hash it is, but we have enough information to know that there was a different password. So we can record up to 4,096 passwords in a time period, which is a lot. If you're getting that high, then it's almost certainly abuse. Okay? We don't really need to know whether you logged in 4,096 different passwords or 5,012, right? It's all bad at that point. So exactly the same happens with AppSuite. So the nice thing is Dovecot Anti-Abuse is sitting behind both AppSuite and Dovecot. Now, the other interesting thing about this is this communication here is via an open API. It's a REST API. It's fully documented. I've actually even used Swagger, which is like a really cool API documentation. Recommend it to anyone. Which means that you can actually integrate other systems here. And we've actually got customers who are talking to us about integrating their SSO system into this. So, if you're using, for example, single sign-on, your own IDP, say with AppSuite, for example, you won't want to do the AppSuite directly here because you actually want to do that in your SSO system. So you can actually connect the SSO system to Dovecot Anti-Abuse Shield using this API, and then everything is going to start working just in exactly the same way. And this is really important because a system like this really works best when it gets data from more sources. The more sources you can get data from, the better. You could even, for example, connect your MTAs. So SMTP authentication, you can connect that to the system as well, and some of our partners have actually been doing that. So the more data you have, the more informed decision you can take. If the bad guys know, hey, IMAP and POP are really good protection now, but I could just hop over to SMTP and start using that and everything's okay, then they will do that because these guys are really good. They're generally very smart people. So we want to get as much data into the system as possible. So the other nice thing, of course, is that, of course, both Dovecot and AppSuite have hooks into this system. They're hooks, they're open APIs. So even if you think, hey, I've just built all of this myself, this sounds great, but I've basically built this myself. If you're using Dovecot, You can use the API. You can essentially just have some kind of bridge to your own system because Dovecot's using this API, and you can just bridge all the data and get all the data out of Dovecot that you maybe wouldn't have got before. So it's a really, really nice modular system for doing this kind of stuff. Of course, just one guy isn't the problem. It's lots of guys that are the problem, right? Brute forcing on a big scale. And this, again, this is where the statistics come into play, because this seems like a bigger problem, but actually this can be much more helpful. The more people, the more logins and the more IPs and things that are being used to try to compromise and brute force accounts, actually this gives you a lot of data, because now you can do a lot of correlation. You can say, oh, this IP was used to try and brute force this account, so any other IP that's been tried to use to brute force the same account, I'm going to block those guys as well. So you can do a lot of correlation of data when you've got a larger volume of abuse going on. So it's really good for doing that. And of course, it's doing exactly the same thing, just at a large scale. Another nice thing we wanted to do was when we kind of tested this with some of our early adopters, they said to us, well, hey, that's great, this data coming from login, we want to be able to take decisions on that, but we also want to be able to take decisions based on a user basis. So I'll give you an example. Let's say we've got you're running a system in Italy or wherever it is, and you say, well, we've got users who they use the basic service and they're only allowed to use the system from Italy. So if they log in from another country, they're just not allowed. We know that's a bad person because they're not allowed to use the system from outside of Italy. So what we do is actually AppSuite and Dovecot will both integrate. They're already looking into user database information, right? They get things like class of service and all the information that's in your user database that determines the parameters of a particular user. And they will actually pass that information on to Dovecot Anti-Abuse Shield as part of the allow question and the report. So now Dovecot Anti-Abuse Shield can actually make use of this data. It integrates already with the GeoIP libraries that come with Linux. So you can start to make decisions based on GeoIP and other things which are in the user database field. Anything that we have about the user, we can make use of that to make better decisions. In the same way that Google are making decisions to give you a really good search, but you don't really know how that works. But they can make really good decisions because they know a lot about you. And just as the similar thing, we can use that information in the user database to make much more informed decisions about whether this user is allowed. And we've actually got one customer that potentially could use it for an upsell. So you go to Nigeria on business and this stops you from logging in, but hey, you can upsell you to the premium class of service, and now you can log in from when you travel abroad. So you get more money. So this is an example where the bad guy wasn't allowed because in Nigeria, but now the real Virgilio Mortarotti logs in from Italy, and of course now he can get access because he is in Italy. So the system is fully clustered. The idea is here we're trying to make this scale, and you want to have a consistent view of data. So Dovecot Anti-Abuse Shield does cluster this information. So whenever we get a report, we're going to send that around all of the servers in a cluster. We looked at doing sharding. Sharding works really well for scale, but it also has some performance implications typically because you've got to send the data around and ask the data from different servers. So at the moment, the way it works is it's essentially every database is a full copy of the whole thing, which means it's very, very fast, very, very efficient. You need more memory, but memory is relatively cheap these days. So every server has a complete view of the system, which means, of course, that if you're using Dovecot and your report gets sent to one server, then you log in from any other server, whether it's Dovecot, AppSuite, or your SSO system, whatever, it's still going to know that it shouldn't be allowed. So the kind of features that it does, I already talked about how it can work with different systems, IMAP, POP, webmail, SSO, SMTP auth, anything you want to throw at this. It would be, we really, really be very, very happy if customers are deploying this, not just with our software. This works best when you've got all of the systems which are doing authentication with users are integrating into this platform, because then you get the biggest view of data across your organization. The Lua language really is very cool. I don't know, hands up anyone who's actually used Lua? All right, great. That's actually more than I thought. That's awesome. It's really, really nice language, incredibly flexible. It also has a whole bunch of third-party libraries and toolkits that you can use. So you go to the Lua Rocks website and you can start to do your own lookups within MySQL databases or LDAP or these kind of things, which we don't have to provide support for you because you can just do that from Lua. You just install the right packages and it all works. So we're big fans of Lua. If you're used to Lua, anyone using PowerDNS, the Lua support in that is exactly the same. Actually, I said this was originally developed by the PowerDNS guys, so it was a lot of the same infrastructure. So if you're familiar with PowerDNS at all, you'll be very familiar with the tools the tool set that we've given you here, like the console and the remote access, etc. I said before about the statistics capability, so it's all in memory, it's time window based, so you get this kind of sliding view of time windows, and you can define your own databases. You don't have to stick with whatever we give you by default, like 1 hour. You can say, I want to track stuff over a 5-minute period, which means you can store a lot of data and it won't take up too much memory, or you can store stuff like over a day if you want to, which will obviously use a lot more memory, but you can get a much better idea of what's going on over time. And you can look at that data over the whole time series, so we can aggregate that data for you over the time series, or you can look at individual windows and say, I want to look at this hour compared to the last hour. So you can make very, very sophisticated policy decisions. And these are the 3 main statistics algorithms they're using today, so simple counts, hyperlog, which is this sort of cardinality idea, so you can essentially count things. It's using a bit field, it's extremely efficient. And then count min, which is actually really nice. It's one of my favorites. This allows you to not just say how many unique things did I put in this bucket, if you like, but you can say how many times did this particular string appear in this bucket. So you just throw things in the bucket and you say, okay, how many times did the word Miko appear in this login? So come back and let's say 12 times. How many times did the word Neil come in this bucket? Okay, 24 times. And again, it does that really efficiently in memory. So it's not actually storing any of the stuff as strings. It's all done with bit fields. So it supports DNS lookups. If you want to integrate with a real-time blacklist with RBL, there are RBL providers out there who'll do this kind of stuff. Spamhaus have a list called the SMTP auth blacklist or just auth blacklist. It'll integrate with those. If you've got your homegrown blacklists, you can use those. It'll do various kinds of DNS lookups, reverse lookups, and those kind of things. As I said, it has full support for GeoIP, just at the country level at the moment. We're going to add city-level support in a later release. It's fully clustered. And in terms of the policy, if you know Lua, if you've got people capable of writing, you can write the Lua stuff yourself. Otherwise, we can help you do that. Okay, in terms of what it uses, it's a modern system. We expect to put on a modern OS, so relatively modern OS anyway. So Debian Jessie or Red Hat Enterprise Linux 7. It runs under systemd, so you get all the nice systemd support and the journaling and all of that. Full capability support as well, so we have very, very restricted capabilities for process. And it runs as a standard user. It's not running as root. It doesn't need privileged ports or any kind of privileged access. So in terms of security, it's very well bounded. It doesn't show root, but it doesn't really need to because it's under a very standard user account. In terms of sizing, I said it needs a reasonable amount of memory. If you're storing any kind of statistics over a period of time, you want a decent amount of memory, so minimum of 16 gig. The more data you want to store, then the more memory you need. It's fully multi-threaded. It's actually written in C++ 2011. As I said, it shares a lot of heritage with PowerDNS, and that's what those guys use. So that's what it's written in, which means it's very fast. It's fully multi-threaded. It will use as many cores as you can throw at it, so it will really extract all the juice out of whatever box you put it on. And it'll do roughly 18,000 allow and report requests a second on a single 4 CPU box, which is a lot. Typically, even a big installation, the number of logins per second is nowhere near that number. So it's very scalable. So you really shouldn't need more than a few boxes. So 2, 3, maybe if you're like a huge service provider, maybe 4 or 5 maximum. Yeah, this is installation. It's easy. It's full documentation. We have full documentation as part of the man pages. We also have documentation on the web. All the APIs on our web page, Oxpedia. If you go to that, you can find all the web API, REST API documentation. So it's pretty straightforward. The end of this year, we're coming out with a slightly updated version. We're going to have some improved replication. It's going to actually it's essentially going to replicate the full stats database around underneath, so you don't have to replicate the reports, which is more efficient. It doesn't have to call Lua every time. Also, we're going to have a full blacklist support. So essentially replicated persistent blacklist. So if in policy you decide I'm going to blacklist this login or this IP address or some combination of the two, you can use any kind of key you want. You can blacklist those you can blacklist forever, or you can blacklist them for a period of time, and it'll track them until the time runs out, and then they'll disappear. So you can say, just block this guy temporarily, or block him for a day or for a week or whatever you want. So that's really nice. Again, full API for doing this. If you want to manipulate the blacklist over the REST API, you can do that as well. And then finally, multi-factor authentication support. This is really just done because we have a very flexible, extensible API, so it can return any information as JSON attributes. So essentially, you can send data back to AppSuite or Dovecot or your single sign-on system and say things like, hey, you should ask for multi-factor authentication here. I'm not sure about this login. It's a little bit dodgy. It's a little bit concerning, so you should force two-factor authentication. And we also have webhooks in the next version as well. So you can actually take any of the data that gets fed into this from all the systems that you've connected it to, and then send that data via webhooks to other systems if you want. If you've got some kind of long-term database storage system that you want to track all of these reports, for example, you can do that, and it's all done via webhooks. It's very, very standard. So that's Dovecot Anti-Abuse Shield. That's what it looks like today and by the end of this year. However, we're not satisfied with that by itself. It's really great for tracking abuse kind of as it happens in real time, very, very fast response to abuse as it's happening. But we want to go further than that. We want to build up behavioral information over a much longer period of time. So, for example, if you're using any of the big internet services, Apple, Google, Facebook, those kind of guys, you'll see things like if you log in from a new browser or in a new country or this kind of thing that you haven't logged in from before, you'll see you get an email. And they'll say, hey, we've noticed you've logged in from this new device. Was this you? If it wasn't you, click here. Well, we want to be able to support that kind of behavior as well. So this is about much more long-term tracking. So if you look, what we've just been talking about is this bit here, and everything in this gray box is the new stuff that's going to come in 2.0 next year. This is kind of like what it's eventually going to look like. Whether we deliver all of this is figure out how we go. But the idea is storing persistent information about all of this data over a long period of time, not an hour, not a day, but weeks and months and years. And so the idea is there, we take all of the data and we're essentially using that kind of webhook interface that we just talked about, sending it into a long-term database, and then that's going to have a very, very similar policy language based on Lua that you're going to be able to basically search the long-term data and say, hey, okay, this guy's logging in from a user agent we haven't seen before, or an IP address we haven't seen before, or you can correlate statistics over these long period of time, and you can build up a real picture of user behavior, whether that's a good user or an abusive user, whether that's for a login or an IP or whatever you want to track on, you can build up that picture of behavior over a long period of time and make informed, intelligent decisions on it. And then the second part is this alerting interface, and I apologize, it's a very small diagram, but that means hopefully I'm not overcommitting because you can't read it. But the idea is that you have a notification interface, a whole bunch of plugins to be able to interact via email. Like I just said, you get the email that says you logged in, was this you? But also we want to be able to work with things like the OX native apps. You're probably going to see in some of the later sessions about the native app strategy that we have. But we want to be able to dialogue with you through an OX app because that's a very secure way of communicating with you. So email, yes. SMS, yes. It's sort of relatively secure. It has been compromised in the past. And then the OX app, because the OX app is sort of within OX secure channel communication you can use to securely communicate with you. And we can not only say, was this you, but we can actually have that dialogue with you in real time through an OX app. That's really exciting. I'm pretty sure that won't be in 2.0 though. It'll be in 2.x. So yeah, that's what we're doing. That's the long-term plan for this. So that's where we are today. That's where we want to go with this. I think it's really exciting. For us, I think this is something we haven't had before. Dovecot has really, and apps we have not had this idea of being able to detect and manage compromised accounts, brute force, really dealing with abuse, and hopefully having this as a kind of hub for abuse management across not just OX products, but as much as possible the other authentication systems that you're using within your business. So that is Dovecot Anti-Abuse Shield. All right, great. So I'm going to introduce Greg. Greg Hill is a senior developer for Guard. the Guard product, and he's going to tell you all about where Guard is and where it's going.
Thank you. Thank you, Neil. Okay, well, I appreciate it. I just wanted to go over quickly Open-Xchange. Quick introduction. I think many of you are probably familiar with it. With Open-Xchange, we really wanted to try and bring encryption to the masses here. We wanted to do it in a non-proprietary way, but we wanted to make it easy for everyone. We first started looking at PGP, of course, because it's something that's been well established. It's used, but wasn't used very much. And we had to ask ourselves, why is this not used? I mean, 99% of the people out there have absolutely no idea what a public key is, a private key. They've never created public keys for themselves. They never published it. And PGP just frankly wasn't used out there. But again, it was a non-proprietary thing, something that we felt comfortable with, maybe not perfect security, but one that was well accepted in the realm, and where we wanted to go. So the real objective with Guard was bring it to the 99%ers, if it's not the 99.99%ers that don't even know what the keys are, and how can we make it simple so that people use it? Security is useless if people won't use it. So with the ultimate objective of could my mother use it, we started trying to do Open-Xchange. So just to briefly show Open-Xchange for emails, in case no one's seen it, it's basically as simple as clicking the lock symbol. We just wanted a one step. Do you want to make it secure? Click. That's it. That's all they have to think about. If they have not set up the account before, the only thing they have to put in is their password. We don't need to ask them, do you want a 2048 key? Do you want a 4096 key? Where do you want to upload? None of that. Just what password do you want to use? Great, we got it. Let's go. We take care of all the key management. We take care of publishing the public keys and where it goes. And when they hit that lock symbol, we look up the public keys for the recipient. They don't need to do anything. That's it. They get a little key symbol next to that. They type in the message they want, and off it goes. When a recipient gets the message, they see a little lock symbol in their inbox. They put in their password, and that's it. If they hadn't set up this account, if it's the first time someone emails them a secure email, we created the keys for them. The first time they do this, they'll be asked for a new password. What password do you want to use to secure your system? That's it. Trying to keep it simple for the 99%ers. Decoding the email, there you are. There's just a little PGP symbol there. It's been decoded. And likewise, if you have attachments, we support all the attachments. It looks just like the native UI for unencrypted emails. You can view the attachments. You can save them. The only thing that's new there is you can save a decoded to drive or save an encrypted to drive. Just 2 more entries. Simple. And likewise, we wanted to bring the same thing to files. So if you've uploaded a file already, you can simply just click on the drop-down and encrypt it. Or you can even just drag files. Now we got 2 entries here for normal upload or upload and encrypted files. And likewise, you can click on new and upload a new file that way. Again, trying to keep it very simple so that people will use it. Obviously, there's no previews for encrypted files. So we just have the icon with the lock symbol so that they know it's encrypted. And when they double click on it, they're going to get a password prompt. And it comes up in the viewer just like the native system. So again, trying to keep the flow simple, easy, and something that they can use. But with Guard, we wanted to also handle people that know what key systems are. We wanted to handle those 1%ers that want more control, that want those extra levels of security, that want to control their keys. So we have basically a very simple process where it's very adequate security. It's a heck of a lot better than not using it, and these people can comfortably use it. But for the people who are really much more security conscious, we want to be able to give them those advanced options so that they can take it to the next level. So we, especially in this new version, have set up 2 different levels, the basic user and the advanced user. Where the basic user is just the quick, convenient PGP encryption is used. They don't even need to see the word key. They don't need to deal with their keys, and they can use it on any device. Their mobile phone, their tablets, their desktop computers, and even my mother is capable of using this. Versus the advanced user, where they actually can take control over these keys. They can upload their own private keys. They can keep the private keys on their computer only and not share that private key with the server. And so they really can have that extra level of privacy, an extra level of security, but it certainly adds to the complexity. Something that 99% of the people out there probably would not want to do, but the very security conscious people can do. We want to support that. And likewise, we have the options at that point for the client. You can import it into Enigmail's Thunderbird, GPG Mail for Mac, and do those things that will heavy clients that can handle the private keys and still work well with Guard. So just as a sample of the difference with our security levels, I'm going to start with a basic user, and their drop-down menu is just secure and sign. Those are the only two options our basic user has. And when going into the Guard security options, it's basically just password management. They can change their password. If you've enabled resetting passwords for password resets, that's available. And the advanced settings, it's just you can set defaults, send encrypted or not. Clicking the advanced, however, you get all the key information there. You get public keys, you get your private keys, you can look at fingerprints, you can verify signatures, and all the advanced functions that a lot of people would not otherwise want to deal with. And these advanced users can actually delete their password recovery. So if you want to make sure there's absolutely no way any server could get your password again, you can delete that. And their menus are much more extensive. So that's the basic versus the advanced, encrypt, sign, different MIME types, and attach your public key. So we're trying to have those two different levels there where basically the advanced user who doesn't know the difference, the basic user who doesn't know the difference between PGP MIME and PGP inline versus the advanced user who wants those extra options of those extra steps. New in 2.6, which is the version that's being released in next month, we're bringing a new key management API that we're really excited about. Basically, we want to be extending this to clients like Enigmail, EM Client, and others that we want to become the key repository. One of the biggest problems with PGP for the advanced users is if you have PGP on your phone versus your desktop, you have to copy all the public keys from one to the other. Your key rings are in different locations. If you want to email your friend, you have to have that public key and on that device that you're using. Guard, on the other hand, can be that central repository of public keys. We will manage those key rings so that if you're using your phone, you're using your tablet or your desktop, you'll have access to all those public keys. We're being that central area. Likewise, we know which keys are very safe. If this key was created in a Guard account by a user that was logged in, that's a trusted public key. I mean, it's a verified public key. Versus the public keys that were uploaded to some random MIT servers or other, that's not necessarily trusted. Anyone could have uploaded that key. So we kind of we manage that trust level. We can tell you with fairly good certainty, this is a very trusted key. Go ahead and use it. Verify your signatures with it. And feel comfortable emailing this person because it was created with a logged in account. So we're going to be working with other third-party clients like EM Client and hopefully things like Enigmail to get this key management API there so we can get a broader acceptance of PGP for those people who want to use heavy clients with Guard. And in 2.6, we have a much tighter integration with our Office suite. The prior versions, it did not work very well with documents and spreadsheet files. Now we're very tightly integrated. You can take these encrypted PGP document files and edit them freely, just as you would any other file. So just as an example video, we take one of our Excel spreadsheets. This is an unencrypted version, just to demonstrate what it looks like. To encrypt it, we just go up and hit encrypt. Just clicking that little symbol. And then we get the key lock. That's all the user had to do. To open it, they just double click it, and here they have to enter in their password. And boom, the file comes up. There's really not much else to it other than we just did that extra step of verification. And just to show how the management is, we'll just change that from 2014 to 2016 and close the file. And just to illustrate again, we have the exact same versioning we do in our other basic unencrypted system. And you see now they just have the PGP suffix to it. And again, double click on it, enter your password, and there it is with that recent change that you made. So it's tightly integrated. It's very easy for them to open encrypted files, and there's really no reason for them not to encrypt it at this point. So our roadmap for upcoming is more tighter integration with clients. We would really like to see this key management out there. working with them so that you can use it in multiple devices for those people who want heavy clients. Our mobile app should be coming out soon for our mail, and we're going to be integrating with them. And we're just trying to give it more options, more convenience for people to use PGP encryption, making it so that advanced users feel comfortable using it, but the basic users, my mother, can use it without any problems.